Hey everyone, welcome to another video. Today we are going to be working through a LeetCode problem. Before we get started, it would help us out a lot if you could like and subscribe, check out our other videos and our Patreon in the description. So today we have a LeetCode problem. It's called n-repeated element in size 2n array. It's a very common LeetCode and interview question. Hopefully we can work through a couple solutions, and if you think of any others, then feel free to comment them below. So to start off, the general idea with this one is that we're given an array of size 2n, and there are n plus 1 unique elements. One of those elements is repeated n times. So basically, by reading that, you can see that half of the elements in this list or in this array are going to be the same. So right off the bat, you should see that there's probably some math component to this. There's probably a trick we can use. But if you didn't initially come to that, we can work through a solution using a hash map. So hash maps and dictionaries or counters, whatever you want to call them, they're very common in technical interviews. They allow for O1 lookup time, which can help a lot with your runtime. So to start off, we're going to be using this counter type. It's from the collections library in Python. So basically the idea behind this, what we want to do is we want to count up all of the elements in this array, or count up the frequency of these elements, because we know that if at any point we see that an element appears more than once, then that is going to be the element that we want to return. So for this one, we can start off by just making a count, and we will make this counter type of A. So what this is going to do is basically populate some dictionary type, more or less, with each of these elements, these unique elements, as the keys, and then the frequency, or the count, as the value in that. So as I mentioned before, just based off these examples here, this should return 3, this should return 2, and this should return 5. And we can see that if at any time the element appears more than once, we know that is our answer. So all we have to do now is loop through what we just created there, and if at any point the count of the element is greater than 1, so in this case here on the last iteration of this loop, we're going to see that 3 appears more than once. So if at any point we see that, then we can just return the element that we get to. So why don't we just go ahead and run this and see if we get the right output. And we do. So we get 3, 2, and 5 for these here. So talking about the runtime of this, so to create these counters, if you think about just populating a hash map, what we're really doing is we're initializing some dictionary. If we didn't use this counter type, we would initialize some dictionary, and then loop through our entire input list here, so O of n, and then every time we come to an element, we would just update the counter associated with that element. So this here is going to be an O of n operation, and even though we do use, this is something, if you do plan to use Python for your interview, something to note is that if you're using a lot of these built-in types or built-in methods, it's really good to have a pretty solid foundation of their runtimes and any space that they may use, because you may not realize it, but sometimes your time complexity can kind of get out of hand if you're using a ton of these built-in methods here. Especially if your inputs are small, you're not going to see like your computer won't hang or anything like that. But if you're basically constructing a counter, you have nested for loops all over the place, it can kind of get out of hand. So it's always good to know when you call these built-in functions the runtime under the hood, basically. And then for what we actually wrote, this here is also an O of n operation, but so this would ultimately lead to 2n or big O of n for worst case. Now the thing is with this one though is that now we have a counter, which I mentioned was pretty much like a dictionary. So this is also going to be time and space of O of n. So this is a time complexity of O of n, space complexity of O of n. So after you came to this one, the interviewer may say like, this is great, the linear runtime is good, but can you think of a way to do this with no extra space? And then this is where that math background could come into play if you have that. So I like to think of this question as somewhat like a variant of the Pigeonhole Principle in a way. So basically if we look at this input list here, we see that for any subset of this array of size 4, at least within the array of size 4, the answer, what you're trying to return here, is going to appear at least twice. So if we take any subset of this array here, we see that 5 appears twice here, 5 appears twice there. So any way I try to slice this list up, I will see that 5 appears at least twice. And no matter how I rearrange these elements in this list, that will always hold true. So now, because we're using Python, we have this cool thing called negative indexing. So another way to say what I just mentioned with the whole, basically there'll be 2 within 4, is that at any given time, if we're at the element that we want to return, so 5 in this case, another 5 will be no more than 2 places away from where we are. So even if we start from the front here, if we kind of think of this array as a circular array, that's kind of the trick here, we can see that if we go backwards, this is 1 away, there's a 4, and 2 away, we have a 5. And again, no matter how we rearrange this, if we loop through, we will always see that what we want to return is no more than 2 spaces away. So to do this, we can no longer have to add any extra space, so we can keep constant space and maintain our linear runtime. So for this, why don't we just loop through our input list. And then all we're going to do now is just check positions 1 and 2 away from wherever we are, whatever I is in this case, right? So if A at I minus 1 equals where we currently are, or, because this is 1 away now, so we just covered when it's 1 away, so if the 2 numbers were adjacent, or if it's 2 away, so in that case it would be A of I minus 2 equals A of I, then we know that A of I is going to be our element, so we can just return A of I. Let's just run this and make sure that we have no bugs. And we see again, we have 3, 2, and 5, which is what we expect. And now this time, for our runtime, we maintain that linear runtime here. So this is going to be O of n. But the difference is that this is the only looping we're doing. This is the only, basically, computationally intensive task that we're doing for this whole thing. Because now all we're doing is just comparing. And basically we have that, O of 1 lookup for these arrays here. So basically now all we did was we had a linear solution in both time and space, but then we improved it by reducing our space but maintaining our linear runtime. So these are a couple solutions. If you have any other solutions, feel free to comment them below. There's a couple fun ones that you can do with Python. But yeah, so thank you very much.